Welcome to our second topic, surface area. So this slideshow, once again, it's going to be kind of abstract, like rectangles on cones and all that, and you'll maybe be wondering why. Why am I doing this? But by the next one, when we're talking about volume, we're going to bring in some things you might actually see in your work, so bear with me. So when I talk about surface area, we are moving to three-dimensional objects. So cubes and spheres and all that, but we're not thinking about what they hold, we're thinking about the area, the outside area of the object. So basically what you would paint if you were painting it. It's going to be square, it's an area, so it's square units. So when you're doing this, what you're looking at is how many sides am I looking at, and what is the shape of each of those sides, and calculating that. And the big thing is to look at whether anything's covered and wouldn't be included in your calculations. Are you missing sides, or are you missing a lid to a paint can or something like that? So the types of shapes that we're going to be looking at are prisms, and prisms are when we just take our normal shapes, like our circle, unexpected highlighter, there we go, circle, triangle, rectangle, anything, stop sign, whatever, and we add that third dimension in. So suddenly we have depth, and that depth creates extra rectangles that we have to find the areas of. Cones are when we have a circle, and then we have a nice smooth-sided thing added on, like your ice cream cone. Pyramids are like the ones in Egypt, where you have a bunch of extra triangles, and spheres are just round, like balls. So first we're going to look at our rectangular prisms. And here's your surface area formula. And here's what it looks like on the formula sheet. So they're telling you, make this one the width, this front one the length, this one the height. It doesn't matter for a rectangular prism. As long as you're consistent, I don't care what you call everything. So here I might do this, but as long as you account for everything. So what have we got going on here? We have a box, and a box comes with a top and a bottom that we can't see. And they have the same dimensions, and looking at my picture right now, a top and a bottom is going to be L width. And we need two of them, one for each. And we have a side that we see here, and we have another side that we can't see. And what are the dimensions of that? Using L again, but this time using H. And then we have a front that we see, and a back that we don't see, but they are the same dimensions. And they are W times 8. To WH times 2. You put that together, you're back to our surface area formula. And this little guy here doesn't rotate because I'm not using the slideshow version of PowerPoint right now, but if you go to the slides, you can make this guy spin around if the slides are downloaded. So let's try an example. Here's front and back. Here are the sides. And here's top and bottom. But that doesn't matter. Just give your dimensions a name. I'm going to call this the H. I'm going to call this a W just to mix it up. I'm going to call this the L. And put them in the formula. So from the previous slide or your formula sheet, this is a formula for surface area of an entirely closed rectangular prism, which is what we have here. And make sure you get things in the right spot. So I said L was 3. 3 times 9 for W. W is 9, height is 6. L is 3, height is 6. So respecting order of operations, you have to multiply everything by 2, but first you have to do some multiplying inside. And then because of the brackets, you have to do some addition inside. 27 plus 54 plus 18. It doesn't matter what your brackets look like, I just give them different looks to try and tell them apart. 198. You started with centimeters, you end up with centimeters squared. So moving now to triangular prisms. So if you take a triangle and you add some dimensions. Looking at our picture here, we have our good old triangle here, and I'm going to keep the base as being B. Now, in all these 3D things, we started using the height as being this, so I have to call what was previous, like base times height divided by 2, something else, and here they've chosen to call it L. So be it. A and C are going to be the two non-base sides of the triangle. So there's all the dimensions we need to find the surface area of a triangular prism. And what does this bad Larry look like? If we unfold him, we have a triangle, and we get these rectangles shooting off all the triangle sides. Oh my. And they are all h long, but they have a different dimension that's A, B, or C depending on where they are. And then you have that triangle, which is 1/2 base times length. And because I have two of them, 1/2 base times length times 2 is just going to give me base times length, which is this guy in the formula. So here's add all the rectangles together, 1, 2, 3, and then add the two triangles in. So doing some math with that. Looking at our diagram, I'm going to label things. So 3 is the base, 1.6 is that triangle height that we're calling L now. 4 is the depth or the height or the H. I'm just trying to not use the same things. And then it's hard to tell, but 2 and 2.5 go here and here. So I'm going to call this one A and I'm going to call this one C. And in fact, I'm going to list all of these so it's easier for me to look at when I'm doing math. So I have B equals 3, A equals 2, C equals 2.5, H equals 4, and L equals 1.6. My surface area formula is AH plus BH plus CH, the 3 rectangles, plus 2 triangles, which is just BL. Flip my page here so I have the work. Alright, so let's do some subbing in. A is 2, H is 4, plus B, which is 3 times 4 again, and plus C, which is 2.5 times 4, and then that BL, which is 3 times 1.6. Running right off the page there. Okay, a little messy. 2 times 4 is 8, 3 times 4 is 12, 2.5 times 4 is 10, and 3 times 1.6 should give me 4.8. Add those 4 numbers together, 34.8. Started with centimeters, finish up with centimeters squared. Cylinders. So these are our soup cans. They're also our hot water tanks. Pipes are cylinders. You have a lot of applications for cylinders. Alright, so what do we have here? We have a circle for the top and a circle for the bottom. And then we have this wraparound on the side. So this thing here. And I notice that if I were to pull off the side, this distance wraps around the circles, so it's a circumference. And then we have our height that goes here and here. So when we think about the two circles, we get pi r squared for the top and the bottom. There's 2 of them, so it gives us this. And if we think about our rectangle, that makes the label of the soup can. C is 2 pi r. We know that already. So if we do base times height for a rectangle, area would get 2 pi r h, and that's this part of the formula. So let's take that to an example. So we have a pipe. I'm going to cap it on one end, and I'm just going to assume that, oh my land. Sorry, pipe, sorry. It's 23 inches. And it has a radius of, first it has a diameter of 1.5. which means if I want a radius, which I do, I'm going to take 1.5, divide it by 2, and get 0.75 inches, or 3/4 of an inch. Okay, it's capped on one end, so I'm definitely going to have a circle at the bottom, but it's going to be open at the top. So our normal formula for surface area of a cylinder is 2 pi r squared for top and bottom, plus 2 pi r h for the distance around the lateral surface. For us, we only need one of these circles because it's open at the top. So remembering to change the formula for your situation. So I'm going to take that pi and multiply it by 0.75 squared. And then for the wrapper, 0.75, and the height of the pipe, or the length of pipe, which is 23 inches. And I do that math, I end up with 1 point something like this, and it's going to be added to, sorry, actually that's messy. It's going to be added to 108.33, and you're going to get 110, and I'm just going to round a bit, 0.1 inches in, square inches out. Moving away from our prisms and into the more unique 3D shapes, we're going to look at cones next. So here's our dimensions. Our height is back in like with an H, and we've got a radius down here because there's a circle at the bottom of the cone. So we always have a circle. And then we kind of have the wrapper is a little wonky shape, so we're not going to think about the math that derived that. We're just going to be like, oh hey, the wrapper is pi r s. But what's s? S is the slant height, and it has this symbol here. And what I can trick you with cones is if I give you the perpendicular height. So not a big deal, just noticing that when you look at that, you have a right triangle where the slant height is the hypotenuse, and here's the height, and here's the radius. So you can figure that out using Pythagorean theorem. So just be aware of that. Our cone example, for some reason you have a tank that is shaped like a cone. Here it is. It has a radius of 2.6, and it happens to have a height of 3.2 meters. So our formula for the surface area of a cone is that lateral surface plus that single circle on the top or bottom. Okay, I have an H. I don't have an S, but I'm just going to take that right triangle that I formed to find my slant height that I need for the formula. So once again, S squared equals R squared, 2.6 squared, plus height squared, 3.2 squared. And that should give you 17, which means S is going to be the root of 17. And that is about 4.12. So now we can go over to my formula. I'm going to move it over a bit here, so I get 3.14 times the radius, 2.6, times my newly discovered slant height, 4.12, and I'm going to add the area of the circle. 2.6 squared. .2, and when you add those two numbers together, you get about 54.9 meters squared. Kind of like cones, but more angular, we have prisms. Now this is a formula on your formula sheet, and you'll notice it says area of the base is b squared. So it's assuming that this is a square-based pyramid. And it doesn't have to be like that. It can be a triangular-based pyramid or a rectangular-based pyramid, but this formula is for a square-based one, so just bear that in mind. What do we have? We have a base, B, and then we have these pokey triangles unfolding off the base and coming together at the vertex or the apex. And their heights are S. So once again, we need that slant height. Okay, and we may have to use Pythagorean theorem to find it from the actual height. That is fine. When we add up 4 triangles, you end up with this, because it's 1/2 bs times 4, which makes 2bs, and you have b squared, or b times b. Relatively simple one. This is S, this is B. Our surface area formula, 2bs for the triangles plus b squared for the base of the pyramid. And then we're going to have 544 total for the triangles and 256 for the base, the square, equals 800 square inches. Easy peasy. Spheres, so your balls. All you need for this one is a radius, and you can figure everything out. Very simple formula for the surface area as well. Here we go. 4 pi r squared. Don't cube the r, that's for volume. So just don't change the formulas because you're trying to find something different. Okay, so in this case, 4 is given, pi is a constant, and the only thing that goes in is that 5 meters, which is already a radius. Do the math, you get 314, and that will be meters squared. So those are all our basic shapes. So now let's kind of smash them together and make composite figures. Okay, so we're thinking outside surfaces only. So if we had something very, very terribly drawn here, where we had kind of like a staircase, and we wanted to know the surface area of this little step ladder or whatever it is, yeah, it's easy to be like, oh, here's, you know, rectangle X and rectangular prism X and rectangular prism Y, and I can find the surface area for all of X and all of Y. But what you need to pay attention to is that in here we are not including those areas. So the base, the bottom of rectangular prism Y, I don't want in there. And part of the top of rectangular prism X, I also don't want in. So break it down. Don't blindly go in and use the formulas that are given on the formula sheet. Just make sure you know what parts of those formulas you need. So our first example of 2 for this is this situation. So kind of like a sideways propane tank, or, you know, like a compressor tank. What do we have? I'm going to color it, half a sphere up here. Conveniently, I also have another half a sphere down there. So I've got a whole sphere. And the surface area of a sphere is 4 pi r squared. So that's awesome. What else do I have? I have the middle part, which is in the form of a cylinder. But this cylinder has no top or bottom. So I have to be careful, because surface area of a cylinder is 2 pi r squared plus 2 pi r h. I'll make some labels here. That's r, that's going to be h. But I don't need the top or the bottom of the cylinder because that's interior. It's not on the surface. If I was painting it, I wouldn't see that. So I have to be careful to drop this part of the formula. Like, don't calculate the area of the top and bottom of the cylinder. So our total surface area, in this case, we can just kind of smash it together in a single formula. And then we can sub in our values. Radius for both things is 2 meters. So it goes into this formula for the radius as well, and then we have that height of the cylinder being 6 meters. And when we do this math, we're going to get about 50.24 for the first part from the sphere, and from the cylinder we're going to get 75.36. And our total surface area, outside surfaces only, 125.6 meters in, meters squared out. Last example. So we have a box, a rectangular prism down here, and then it looks like we have a cone on top. But what I see is I'm not going to have any exposure to the bottom of the cone or its footprint on the rectangular prism. So let's draw that up a bit. So here's my rectangular prism, and I've got an area that I don't want. So when I think about the surface area for a rectangular prism, I'm going to use that too and make sure I get the sides and tops and fronts and all that. But I don't want the circle that the cone makes. Now looking at the cone, I see that all the way across it's 9. So the radius must be 4.5. Great. So I know that I need to take off a circle that has this formula, where r will be 4.5. So let's do some illustrations here. So I'm going to color out what I'm going to take out. So I'm going to take my yellow highlighter and I'm cutting out that circle, which corresponds to this little thing that has been tagged onto the surface area formula. So just doing that math, trying to make sure I have enough room. My dimensions that go into the rectangular prism are the 9, the 5, and the 17. So 9 times 5 plus 5 times 17 plus 9 times 17, and I have to subtract 3.14 times 4.5, half that 9, squared. This will give us 45 plus 85 plus 153, and we're going to subtract 63.6. I can do all that math because of order operations, and then I'm going to make sure I add these three numbers, then multiply by 2 after. 566, subtract that 63.6, 502.4. So just kind of giving that some color. Let's make it pink. What have I found? I have found this part of the box to be 502.4. So that's all this area has been accounted for. And now I just need to get the part from the cone. So looking at the cone, I know that my surface area formula on my formula sheet tells me that a cone is pi rs plus pi r squared. So this pi r squared is that circle in the base, and I know I don't want that. That's not exposed, so I'm just going to drop it from my calculations and use pi rs. The other issue is that I have this 10, which is a normal height, in h, so it's not the slant height which I want. But I can find it. Slant height squared equals the 10 squared plus 4.5 squared, because we're using half of the 9. We're going from the center, although this doesn't look like a center. And we're going to get equals 120.25, and when we do that math, take the root, you get about 11 meters. Okay, and I'm just going to box that off so you can see it separately. And that gives us this from HRS. Okay. So now we have 3.14 times the 4.5 radius times the 11. And our surface area from the cone is 155.4. Going to give that some color too. Try and keep it all straight. It's getting a little crazy in here. That's my cone part. The total surface area of the figure is going to be the part from the prism and the part from the cone. So 502.4 plus the 155.4 we just found equals 657.8 meters squared. And that is all for the slideshow, and we're going to do quite a few more examples in the Zoom class.